So this is Chapter 4, Section 4 on congruent triangles. Geometric figures are congruent if they are the same size and the same shape. Corresponding angles and corresponding sides are in the same position in polygons with equal number of sides. So corresponding angles and corresponding, I'm just going to abbreviate here, sides are in the same position in polygons with equal number of sides. So a triangle can only be congruent to a triangle, and a rectangle or a shape with a polygon with 4 sides can only be congruent to a polygon with 4 sides. So 2 polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. So here we have 2 triangles that are congruent. So we would say triangle ABC is congruent to, and if we start here at A, we have to go in the same order. So if we go up to B and then down to C, we have to start here at F and then go up to E and down to D when we name it. So we would say triangle ABC is congruent to triangle FED. So we have to keep it in the same order. Properties of congruent polygons. In a polygon with 3 sides, we know that's a triangle. So we need to have 3 corresponding angles and 3 corresponding sides. So every single angle of this triangle ABC has to be congruent to an angle in the other triangle DEF. So here we see that A is congruent to D, angle B is congruent to angle E, and angle C is congruent to angle F. And then same with the sides. All sides in this triangle have to have a corresponding pair in the other triangle. Same thing in a polygon with 4 points. So we have polygon PQRS, and that's congruent to polygon WXYZ. So in a polygon with 4 points, we have to have 4 congruent angles and 4 congruent sides. Two vertices that are the endpoints of a side are called consecutive vertices. So if we had a triangle here, the endpoints of one side, so we're just looking at this side to the left. So the endpoints would be here and here. So these 2 angles would be consecutive vertices. To name a polygon, we write the vertices in consecutive order. Example, you can name a polygon PQRS as, so if we had a polygon PQRS, we could name it as PQRS following the same consecutive order, or we can name it as Q, so starting at Q, we can name it as QRSP, or we could start at R and name it RSPQ, or we could go the opposite way and call it SRQP, as long as the points are in consecutive order. But I couldn't call it PRQS because then that would not be consecutive. In a congruent statement, the order of the vertices indicate the corresponding parts. So if I had triangle ABC and I was saying that that was congruent to triangle DEF, angle A will have to be congruent to angle D, angle B will have to be congruent to angle E, and angle C would have to be congruent to angle F. So this right here is a congruent statement saying that these two triangles are congruent, and the order of the vertices that you write in this congruent statement indicate the corresponding parts of that triangle or the polygon, the rectangle, whatever the shape is. So now we're going to look at some examples. Our first example, given triangle PQR is congruent to triangle STW. Identify all the pairs of corresponding congruent parts. So we have two triangles here. If it helps, draw out the triangles. So we have triangle PQR and triangle. So if I put P in the bottom right, then I have to put S in the bottom right too. Since P is the first letter to come first and S is the first letter, the second letter has to go in the same spot too. So Q and T have to go in the same spot. So since Q is at the top of this triangle, T will also have to be at the top. And then the third letter, R, since I put that on the bottom right, has to match up with the third letter, W, on the second triangle. So here we have two congruent triangles. Now we have to name all of the congruent angles and the congruent sides of these two triangles. So we know that we're going to have 3 congruent angles and 3 congruent sides. So let's start with the angles. Since P is first and S is first, we know that angle P is going to be congruent to angle S. Since Q is second and T is second, we know that angle Q is going to be congruent to angle T. And lastly, we have the third, R and W, so we know that angle R is going to be congruent to angle W. So now we named all 3 pairs of congruent angles. Now we have to name the sides. So just looking at these two triangles, the pictures we drew, we know that they're congruent, so we have to name their congruent sides. Just looking at the left side and looking at the left side here, we know that these two sides are congruent. So we would say segment PQ is congruent to segment ST. Now we can look at the right sides. So we have QR and TW. So we know that segment QR is congruent to segment TW. And now we can do the bottom segments. So segment PR is congruent to segment SW. And just a little side note here, remember that we can name this segment here SW or WS, whichever way you prefer when you're naming a segment. You could either name it this way or this way, and you're still talking about the same segment because it's the same distance. So you could name this segment WS or segment SW, and it's talking about the same thing. So if polygon LMNP is congruent to polygon EFGH. Identify all pairs of corresponding congruent parts. So we're going to do the same thing, but now we have a figure with 4 points. So we are going to have congruent angles again and congruent sides, but this time we're going to have 4 angles and 4 congruent sides. So if it helps, we can draw out these polygons again. So we have polygon LMNP, so LMNP. Remember, they named this in consecutive order, so we have to draw it in consecutive order. So either you want to start going clockwise or counterclockwise, whichever, but the letters have to be consecutive. So I have LMNP, so it's consecutive. And that's congruent to the polygon EFGH. So if I have the first letter L starting in the bottom left, the first letter E has to start in the bottom left too. And in this example, I went clockwise, so again, I'm going to go clockwise in the second polygon. So I'll have F up here, G up here, and H down here. So naming the angles, the congruent angles, we're just going to go by the order of how they were written. So L will be congruent to E. So we have angle L is congruent to angle E. Next we have M is congruent to F, because those are our second letters that were listed. So we have angle M is congruent to angle F. Then we have the third, which is N and G. So we have angle N is congruent to angle G. And last, we have the fourth letter, P and H. So we have angle P is congruent to angle H. So those are our 4 congruent angles. Now we have 4 congruent sides. So we can look at the pictures that we drew and start with the left side. So the left side is congruent to the left side. So we have segment LM is congruent to segment EF. Next we can start with the top. Next we can do the top. So we have segment MN is congruent to segment FG. So MN is congruent to segment FG. Now we can look at the right side. So we have NP and GH. So segment NP is congruent to segment GH. And lastly, we're left with the bottom segment. So we can say LP is congruent to segment EH. So here we have a polygon with 4 letters, and we're going to have 4 angles and 4 congruent sides. So that's example 2. Example 3, given triangle ABC is congruent to triangle DBC, find the measure of angle DBC. So we're looking for this angle here, DBC. So here we know that these 2 triangles are congruent. We also know that their consecutive angles are congruent. So we know that angle A is congruent to angle D. We were given the measure of angle A, so therefore we know that angle D is also equal to 49.3. So if this angle here is 49.3, now we have 2 angles of this triangle. So now we can find the third, because we know that all 3 angles add up to 180. So we have 90 degrees. Remember, this box tells us that that's a 90-degree angle, plus 49.3. plus x, so whatever this angle is here, DBC, we'll call it x, is equal to 180. Remember, every single triangle, all the interior angles will add up to 180 degrees. So we can add 90 and 49.3 to give us 139.3. And we can subtract that from both sides. And we get x is equal to 40.7. So it was asking us to find the measure of angle DBC, this angle right here where I put the dot. So angle DBC is equal to 40.7 degrees. Remember, it's extremely important to read the question. On the last test, there were still people who were just finding x and weren't plugging it back in. For this example, we didn't have to plug it back into anything. We know that x was equal to DBC. But it's a good habit to get into to just read the question, find out what it's asking, and at the end, once you think you found your answer, go back and see if that satisfies the question that the question's asking. Given triangle ABC is congruent to triangle, this is supposed to be a F here, DFE. I'll just rewrite the whole thing. So triangle ABC is congruent to triangle DEF. So here we know that angle A is congruent to angle D because those are both written first. We can see it here. Angle A is 90 and angle D is 90. Let's see if we can fill in anything else. So we have the second letter is congruent to the second one. So angle B is going to be congruent to angle E. So here it's given that angle B is 53 degrees. So here we know that angle E is also going to be 53 degrees. And now that we have two angles of this triangle, we can find the third, which is what the question's asking us for, to find the measure of angle F, this angle, because we know that all three angles add up to 180. So we have angle D, which is 90, plus 53, plus angle F is equal to 180 degrees. So 90 plus 53 is 143. So we subtract 143 from both sides. So we get angle F is equal to 37 degrees. So we found F. We can check that off. Now we have to find the value of x. So x is talking about the side of the triangle. So we need to find this side of the triangle. We know that AB, so just looking at AB, the first two is congruent to DE. So since AB is congruent to DE, we know that 2x minus 2 is going to be equal to 6. So here we have AB is congruent to DE, so this side is congruent to this side. So we can set 2x minus 2 equal to 6. So now we can add 2 to both sides, and we get 2x is equal to 8. And we can divide 2, and we get x is equal to 4. So those are our two answers to example number 4. Lastly, we have a proof. So we have to give reasons for each of these statements. So it's given that PR and QT bisect each other, and angle PQS is congruent to angle RTS, and QP is congruent to RT. These are talking about the segments. So here we have three things that are given. 1, 2, 3. So let's look at our proof. We have segment QP is congruent to RT. Right here, we have that in the given, so we know that our reason for step number 1 is going to be given. Next, we have angle PQS, so looking at statement number 2. Angle PQS is congruent to angle RTS. We have that right here in the given again. So we know that our reason for number 2 is also going to be given. Looking at statement number 3, segment PR and segment QT bisect each other. Again, we saw that in the given, so we know that our reason for step number 3 is going to be given. So we just stated our 3 givens in the proof and gave the 3 reasons as given. So now we're actually going to do some work, figure out the rest of the proof. So let's look back at our given and make some sense of it. We have PR and QT bisect each other. So remember what bisect means? To cut in half. So we're looking at segment PR and QT, and we know that these two segments bisect each other, so they cut each other in half. So we're going to have these two segments be congruent and these two segments be congruent. So just by looking at step 4, QS is congruent to TS, we just wrote that here by putting these 2 tick marks that they're congruent, and PS is congruent to SR. Again, we just wrote that here by putting these tick marks. How did we know that those tick marks belong there? Because of the definition of bisect. So for reason number 4, we're going to put definition of a bisector. Statement number 5 says angle QSP is congruent to TSR. So we have angle QSP, this angle, is congruent to TSR, this angle here. We know that these 2 angles are congruent because they are vertical angles. So for statement number 5, our reason is going to be the vertical angles theorem. I'm also going to go back to the given, or second one, the angle PQS. So this angle here is congruent to angle RTS. So RTS, this angle down here. So I'm going to put 2 arc marks for those just so we can clearly see that those 2 are given. So next for statement 6, there's a typo in this one. It's supposed to be angle QPS. So QPS is congruent to angle TRS. And we learned this last section, that if we have 2 angles of a triangle that are congruent, so we have 1 is congruent to 1 and 2 is congruent to 2, then the third pair of angles also has to be congruent. So we know that QPS, this angle here, has to be congruent to this one. And the reason for that is our third angles theorem. So this symbol here, I put angles. So the third angles theorem states that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third pair of angles have to be congruent. And lastly, we have what we're trying to prove, that triangle QPS is congruent to triangle TRS, and that is because the definition of congruent triangles, because we have 3 angles of the triangle that are congruent, and we have 3 sides of the triangle that are congruent. So this is the definition of congruent triangles. So these two triangles have to be congruent because they have 3 pairs of congruent sides and 3 pairs of congruent angles. So that is everything you need to know for section 4.4. If you guys have any questions, feel free to send me an email. And if there's time left in class, you can go ahead and start working on the homework.